answered the question. So, all right, let's take a look at a problem here. Just grab this one. We'll do, as many as we can get into today's lesson. So it says one of two supplementary angles is 8 degrees larger than the other. Find the measure of the larger angle. So this is an example of a problem where there's lots of things that might be in the multiple choice. So just be sure you're actually finding the one that they want. If it's supplementary, what does that mean in terms of what it adds up to?
180.
180. So if we call X the smaller, what is the larger angle?
X plus 8.
X plus 8. They add up to 180. Now you got to be careful because when you solve for X, X is the smaller. Sometimes it's good to even like write down what the variable is in that case. Could you solve that for X for us?
Yes. Um, 86.
Okay, so X is 86. So for me, if this were a multiple choice, and I'll just talk about this for this problem. I mean, I would put 86, 94, and then I don't know, something else. 82 and 108 or something like that. But because the larger angle is the one that we're interested in. So this is from the first 3 chapters. So some of this may seem easy, but you got to have content from the entire course here. So let's look at another one for this. All right. So this problem here, it says given AB is 2r plus 7. Sometimes it's good to just start labeling those. CD is 3r minus 1, and BC is 6, but C is the midpoint of the whole thing. What does that mean for us in terms of an equation up here?
2r plus 7 plus 6 equals 3r minus 1.
Very good. Now I didn't tell you what to find here, so I want you to solve for R first.
Okay. Um, 14.
R is 14. Okay, very good. Now, if I wanted, for example, AB, what would you do to find AB?
You do 2 times 14 plus 7.
Right, no big deal on that one, which ends up being 35. But let's say I wanted like AC. What would you do for that?
2 times 14 plus 7 plus 6.
Okay, so you take the previous answer and add that. How about if I wanted like B to D?
3 times 14 minus 1 plus 6.
Right, not too difficult, but you've got to make sure you know what it's asking for. This one could have asked for any number of things here for that.
Yeah.
Okay, just a quick review of parallel lines cut by a transversal. All right, so let's say the measure of angle 6 equals 67 degrees. Could you determine the measure of angle 7 and the measure of angle 8 for me?
Yes. Is 8 67 as well?
So the answer is yes, but so this would you're not going to get a question like this. Now here's what I want to know is why. What is the reason that they are equal?
Because they're same side interior angles.
So the interior is here. The exterior is here. They are same side. Okay, so I'll give you the answer here. It's corresponding.
Okay.
Okay, and that's what I think you would be asked. I don't think you'd be asked to find the angle measure. I think you'd be asked, well, why is it equal 67? It would say corresponding or vertical or alternate interior, linear pair. And that's really important here. So what would be the measure of angle? I'm sorry, did you said angle 7, right? Or 8? 8, right? Yes.
8, yeah.
Okay, how would you find the measure of angle 7?
180 minus 67.
Yes, so that's the y there is probably more important. It's because it's a linear pair. Do you understand what I mean by linear pair? You've got the two angles, same side, like you said.
Yes.
Okay, because that's what I think you would be asked. I don't think you would be asked for like something like that. So let's say I wanted the measure of angle 9. Which one is that the same as? There's a couple of possibilities.
The same as 6.
Okay, I agree with that. Now, what's the reason for that? Why are those two angles congruent?
Alternate.
These are vertical angles.
Oh,
Vertical
vertical.
angles. Okay. Now, measure of angle 9 is also equal to measure of angle 8, and that's what you're about to tell me. Alternate interior angles.
Right.
Okay. Now, there's one more here. I go measure of angle 10. Let's come down here. So the measure of angle 10 equals the measure of angle 7. And the reason is, and this is where it does matter which side they're on. They're in, or it's in region, it's in the exterior, but they're not same side. They alternate. So this one is the alternate exterior angle.
Okay. Okay.
Is that okay?
Yes.
So there's several things that you need to know, and these are almost like definitions. Let me type them here nicely, just in case you don't have them. So we have vertical angles are congruent. Do you get a note sheet for this? I'm sorry, I don't remember if you told me or not.
We do, yes.
You do. Okay, so this is stuff that might be useful in there. Corresponding angles are congruent. Alternate interior angles are congruent. Alternate exterior angles are congruent. Okay, and then you move to the stuff where they add up to like 180. So linear pair adds up to 180. And then you were so if they're same side interior, they also add up to 180. Supplementary, not complementary, supplementary. Adds up to 180. Complementary, I don't think I have that spelled right, adds up to 90. All the angles in a triangle add up to 180. So these are just the few that come to mind, the 9, 8, 9, whatever that is, that come to mind that I think you might see. And they're not going to tell you. They're not going to tell you like, oh, they're congruent or they add up to 20. They're going to say, oh, it's a linear pair or they're complementary or it's a triangle. And you have to then be like, oh, I know these things. So this would be a good thing to recognize when you're looking at it. And there's others. This is not complete. I'll try to add to it. These are the kinds of things you might want to throw on your note sheet there.
Okay, thank you.
All right. New question for you to consider here. It says, if angles 1, 2, and 3 are in the ratio of 6, 5, and 4, find their measures. So whenever things are in a ratio, you're allowed to add like a variable here, 6x, 5x, and 4x. And that's
Right.
what you want to use for each of those here. Now, what do the three angles add up to?
180.
180. Now, which which of these is it? It's one of these down here.
Supplementary.
Yeah, the supplementary. I guess you could say it's a linear pair, but pair to me means two. So I don't remember if it's that. It's one or the other, hopefully they're not both there. So what I'd like you to do is go ahead and solve this for X and then determine the value of each angle here.
Okay. X equals 12.
Okay. So could you find the three angles for us, please?
Um, 72, 60, and 48.
That looks right to me. If these were the three angles in a triangle, and don't assume that I've drawn it to scale, how would you label this triangle? What's a word that you could use to describe the sides and the angles of that triangle with these angle measures? Okay, so if you're stuck here, this is more vocabulary, but that's the stuff you forget. Do you remember any words that refer to sides or angles in terms of the type of triangle that it could be?
Isosceles.
Okay, so isosceles.
Equiangular.
Yep. Sorry, go equiangular. So some of them have a corresponding one. So like equiangular corresponds also to equilateral. So that's all sides, that's all angles. Isosceles generally refers to sides, but it also refers to angles. So I guess we could go both ways on that. How about if then that's what this one is none of the sides or none of the angles. Do you remember any of those?
No, I don't.
So obtuse is one that comes to mind. But you could also throw it over here. I'm sorry, obtuse. Sorry, I have this wrong spot. Obtuse and acute. Those are two possibilities. And then on the left here, it's scalene. So scalene means no sides and no angles are congruent. So it kind of overlaps. But this one is also considered an acute triangle because all of the angles are less than 90. And then one of the last words you might see is a right triangle there. These are just things that you want to have jotted down. So you're not like, oh, I wonder what it is. Wonder what that means. Things like that. Any questions on that?
No.
Okay. All right. Here's one of these parallel line problems we'll look at. This will be the last one of these we look at. Okay, so it wants you to find the measure of angle 1 here, and it's easy to say a number that like if this were multiple choice, there's probably a few obvious options. You're like, okay, there's one that's going to be 140, 40, 70, 110, and probably I actually don't think any of these are right, but just keep that in mind as you might think to work through this. Any idea how to start a problem like this one?
Is it you said 140 and 70 equal to 180?
So like a third angle adding up to 180?
Yes.
So this, yeah, so this one is one of those where you have to add a line, parallel line, and that helps you define some other things in this triangle or in this. So do you see how this angle down here, what is the measure of this angle down here? So let's call it E. So imagine D and E are here, and that's 70, what would this angle right here be?
Also 70.
Yeah. So that's maybe hard to see. This 140 is also the angle over here,
Okay.
but then what would this angle on the other side of it be? The second one here. What do these make up when they're on a line?
180. So
Yes. So
40.
40. Yep. And so then you could combine those two angles to make because that was the
110.
yeah, that was the original problem, was asking for these together. So something like that.
Okay, right.
All right. Here's another problem that I like. Okay, so two consecutive angles of a parallelogram are in a ratio of 7 to 5. Okay, so it'd be good to draw a parallelogram, your favorite parallelogram. We'll do a little review on this stuff, parallelograms, quadrilaterals here. So two consecutive angles, like that means angle 1 and angle 2. Those are consecutive. If you don't like those two, you could choose like the one over here. The point is they're not opposite, not opposite. Okay,
Right.
but
Okay.
they're in that ratio of 7 to 5. So what do you remember from an earlier problem how we manipulated that, or we wrote that differently?
Add an x to them.
Yeah, 7x, 5x. Now the consecutive angles here, if you envision these are parallel lines, because they are, they're same side interior. And if you go back to our list, what do you remember about same side interior?
That they're 180.
Yeah, they add up to 180. Okay, so again, like what I want you to do here is I want you to solve for x. So it's like 5x plus 7x or 7x plus 5x, doesn't matter. They add up to 180. And solve for x and then find the two angles, please.
Okay. X equals 15.
Okay, give me those angle measures next.
105 and 75.
Okay, now me as a person that like looks at these, like I can reasonably say, oh yeah, this is the obtuse angle because it's greater than 90, but like I visually see that, and that this one down here, 1, is the acute angle. Is that clear for you, or do you want us to kind of talk about how to do that? Because when they give you problems like this one, you don't necessarily know which one is the larger just by looking at it. You have to calculate it.
No, I think I'm okay. I think that makes.
Okay, let's say, what is the measure of angle 3 over here?
Um,
And it is a
was that
parallelogram.
175?
Yes. And how about the one over here down below?
105.
Yes. So it's always true that any two consecutive angles add up to 180
Okay.
in a parallelogram. There's a lot of caveats in math, exceptions, if you will.
Yeah.
All right. Okay, so I'm going to draw something here. What is the most general name for this shape? It's one word. It's like Wheel of Fortune. You can have somebody start filling in letters here. Counter is it's counting down here. You know, everybody's guessing. Okay, let me give you an easier one. What is this called right here?
triangle.
So why do you know that it's a triangle? Like, other than I know you've seen it many times, what is like imagine you had to explain this to cousins coming in and they're really young and you're like, it's a triangle because, what would you say? So what's the simplest way to describe this as a triangle?
Because it has 3 sides.
It says 3 sides. How many sides does this thing have up here?
4.
4. So what is a 4-sided polygon called?
Quadrilateral.
Yes. Now, I don't know if your instructor's big on, names, but do you remember what a 5-sided polygon is?
Mm,
Pentagon.
Pentagon.
Yep. 6-sided is a hexagon, and it goes up from there. I don't know. I don't know that it's reasonable to, I mean, some are reasonable, I guess. Like, I mean, Pentagon's a government. You see that in Washington, but hexagon is 6. I mean, that you'll see that a lot in this course and in standardized prep stuff. But 4-sided shape, that's a big deal here. Now, I've drawn this. I made this really awkward because what you wanted to see, and I get this, like, you wanted to see, oh yeah, that's, if I asked you what that is, you might say it's a parallelogram, but for sure it's a quadrilateral, right? It's got 4 sides. Okay. Here is another quadrilateral. Okay. Does it have 4 sides?
Yes.
Yes. And here is yet another quadrilateral. Let's see if I get that in there. Okay. Now, here's the difference between these 3 groups. In this one on the left here, there are 2 sets of parallel sides. 2 sets of parallel sides. And in a trapezoid, how many sets of parallel sides are there?
2.
1. See, these are not parallel. Do you see that?
Oh.
A trapezoid's like a triangle that's chopped off at the top, but it's only got 1 set of parallel sides. Now, a kite has how many sets of parallel sides?
None.
None. Is this the first time you're seeing this?
No, we went over
Okay.
it.
Okay. It's just not in the short-term memory.
Yeah.
It's in the long term, and we're figuring out how to get to it and access it. But yeah, so quadrilaterals. So quadrilaterals are broadly defined as those that have 2 sets of parallel sides. That's a parallelogram. I mean, you do a lot of work with parallelograms, but then there's this nice progression, like, oh, if it's only got 1 set of parallel sides, it's a trapezoid. And if it has none, it's a kite. And there's variations on these, like there's an isosceles trapezoid, there's a right trapezoid, and then within parallelograms there's a bunch of other things. There's rectangles, rhombus, and squares. But the main differentiator is the number of sets of parallel sides. I don't know, maybe that's interesting. It should be presented that way because it's a nice, easy way to break them down. So my next question to you, or thing to have you look at here, is this problem here, which is, this means parallelogram. Okay, which is important. That means, and with a parallelogram, you get a lot of nice things. Because they're parallel, you get that opposite angles are congruent. F is congruent to H, G is congruent to J. You also get that opposite sides are congruent, opposite sides are congruent. You also get that same side interior add up to 180. You get a bunch of stuff here. I'd like you to try solving this problem for angle F. And then I also want, of course, well, actually, I already gave you G. So however you want to do that, doesn't matter to me. But let's have you solve for angle F. I would use the same side interior for that.
Okay.
I think this is a parallelogram. I don't know why they would. Just double check that your book uses that notation. Yeah, that looks right. Okay. I'm surprised they'd ask you for letter F. But so this is 40. So this is 140 degrees because they're same side interior. They add up to 180. So if
Yeah.
that's the case, now I want you to find, before we do B, we're gonna do C, which is value of X. I want you to find the value of X, please.
Okay. X equals 7.
Okay. And what did you do to calculate X? What did you set equal, or what did it add up to?
4x plus 12 equals 40.
Good. Now it would also work if you were to write 140 plus 4x plus 12 equals 180. That would also work because when you subtract 140, you get 4x plus 12 equals 40. Okay, very
Right.
good. Now I'm going to write in some of the other angles here. An angle J is 40. What do all four angles add up to in a triangle? Or I'm sorry, in a quadrilateral. What do all four angles add up to in a quadrilateral?
360.
360. Now, do you remember the formula to find the sum of the interior angles?
N minus 2 times 180.
Yes. Now, this would be probably a good thing to put on your note card because, I mean, there's no reason to remember that except for this class. Nobody's going to come up
Right.
to you on the street and say, hey, what's the measure of the interior angle? Sum of the interior angle.
Right.
I mean, it's just the way it goes. Like they might ask you, well, who's the president of the United States? We should know that. I'm not sure this is, something you would need to know, but it is in this class. So after we talked about the sum formula, we talked about what the actual angle, and this is very important. It's for a regular polygon. Do you remember, or could you tell me what regular means when it's referred to as a polygon or regular polygon? It's the hint is it's about the sides and the angles.
That
So regular means that all sides and all angles are congruent. Okay, so
okay.
that's really important here. So I'm gonna draw two different hexagons. Okay, the first one will be a regular hexagon. I'm gonna draw it as best I can to make it really nice and something that actually looks regular. Okay, this one on the left is a regular hexagon. Okay, it's got 6 sides, but all the sides, all the angles are the same. Now I can do this. Is this also a hexagon? Does it also have 6 sides? 1, 2, 3, 4, 5, 6. Yeah, but this one is not
Yes.
regular.
Okay.
Now, did you guys at all talk about convex polygons? Convex?
I think so.
It feels really specific. I don't know that I want to even talk about it, but some of the ones I've been drawing are convex because I'm trying to give them really like extreme looking ones. And concave. I'm sorry, concave. I'm giving very extreme, like these are actually concave that I've been drawing. But you have to be very careful here. Like the sum is this formula always works for the sum, but when you want the regular polygon, that's when you can divide this formula by the number of sides. It doesn't work for this non-regular one.
Okay.
So what I mean by that is if you wanted to find the interior angle for this hexagon over here and you wrote 6 minus 2 times 180, and then you divided by the number of sides 6, you will get 120. And that means that every one of these is 120.
Right.
And that means that all the sides are congruent. But that's only for a regular hexagon. Over here on the left, the sum is still definitely 6 minus 2 times 180, okay, which ends up being 720. But all that means is all these angles add up to 120. Sorry, 720. It does not mean that like they're all the same. That's what I was trying to make clear. So
Oh,
like
okay.
so like the sum formula always works. Doesn't matter whether it's regular or not. But this like interior angle formula only works for a regular polygon because it assumes that all of them are the same, that are all equal.
Right. Okay.
Any questions on that?
No, thank you.
Okay, now I got way away from part B. We're going to grab this. I'll have you do part B. I'm thinking of things to feed in as we go, so sometimes it's a little scattered. I'd like you to do part B now, which is to find the perimeter. You do have to solve for X. I don't think you can assume that it's the same X, but maybe it is. Wait a second, FG. Oh yeah, I'm sorry. You actually do have to use their X. So you found that X was 7.
Yes. Um, 58.
Okay. How confident are you in your answer?
Um, pretty confident. I always am until you say how confident are you in your answer.
Well, I do that randomly. It's more just to get you to buy in that you should be more confident in your answer. Because I'd rather you be like completely confident, even if it's wrong, than to like have this uncertainty, especially before a final. You're like, nope, it's right. Like I want you so confident when you submit the test, you're like, teacher, grade it right now because I know I got them all right. That's the confidence you want to have going in there. And I'm not saying you should do that tomorrow, but that's what we're trying to get you to buy into. Okay, and that is correct.
Okay.
All right, let's look at another question here. 15. Okay, so this is a little bit harder. The important thing here is that you recognize that this is a parallelogram, and you know something about opposite angles and then same side angles. So could you set up a couple of equations here for me or more and tell me what you come up with? I'll take anything that you feel like is true, but I'm looking for some mixture of these over here on the for this.
3x plus y equals 5y plus 20.
Okay. Now, what is the, like, let's say I gave you this in algebra class, what would be the problem with this equation if I said to solve it?
There's two variables.
Yeah, so that means you need a second equation. What will be what will be your second equation?
Just 5x plus 10.
But you have to combine it with something. Like you can't leave it on its own. What are you going to combine it with?
Can you do 5x plus 10 plus 5y plus 20 equals 180?
Yes. So you actually have some choices here. So you said 5x plus 10 plus 5y plus 20 equals 180. So that's good. Yeah, that's totally fine. What could you also use angle A? Could you
Yes.
go a plus d equals 180? Yeah. Okay. Now I don't know if you're going to get this. This is a system of equations. Are you allowed to use a calculator like a TI-83 thing on your?
Yes.
Okay, so you could do a lot of things. You could graph, you could use the matrices, you could use substitution. Anything stand out to you to do for this?
Substitution.
Substitution works really well when you can solve for a variable. Okay. And you could kind of get away with doing that in the second one here. The reason is, let me write this, it's 5x plus 5y plus 30 equals 180. Because there's a 5 in everything here. Actually, let me move that over. 5x plus 5y equals 150. Because there's a 5 in all of these, you could divide everything by 5 and get it down to x plus y equals 30. That's one reason why you would use substitution. Other students in your class might take this first equation here, 3x plus y equals 5y plus 20. They might move the 5y over, 3x minus 4y equals 20. And now you've got these two equations, but in standard form. And a lot of students would use elimination, but you could use substitution because you just have to solve the top one for x or y and put it back into the other. I don't remember how much of an emphasis there is on like the algebra in your class. It depends on the teacher, of course. But the broader idea is like in geometry, when you're not doing proofs, you're either setting things equal to each other or they have to add up to something. And that's just the nature of this course.
Okay, right, got it.
So if you're stuck and you're not sure what to do, all right, set it equal. Maybe that adds up to something, but at least take a step. Maybe it works. Maybe it works on, one extra problem on this. Okay, so we got about 10 minutes left. Sometimes through this review, students say, oh yeah, I can we do this? I remember, I don't remember this, or I'm not sure about this. Are there some other things that you want us to work on that I've not covered that you're remembering, or should I just keep going, finding questions? What would be best to help you?
I think I'm okay. I don't have anything.
All right. All right, here's a few more problems. So, sorry, that didn't snip in very well. Let me make get that a little better. Okay, so it says find x, and x is in a couple of places here. There is kind of a like a direct short way to answer this, and then there's a more like, not a longer way, but you have to maybe use something else. Does anything appear to you like, or you're like, oh, it's this? Can anything jump out to you with this problem?
7x minus 30 plus 40 equals 180.
Why did you add 40?
Because it's opposite interior.
That would be true if the lines were like this. So the only thing you can find is, so let me see. So what you said would work if it looked like this, like if this were 7x minus 30 and this were 40, that would work.
Okay.
But there's no other like line to draw to. Okay, so here's option one. Option one is the exterior angle theorem, which is different than alternate exterior angles. What it says is that this exterior angle equals the sum of the other two.
Right, okay.
And but it has to be the exterior one. And the reason is like let's say you're like, you don't remember that. You're like, all right, let me call this y. So 7x minus 30 plus y equals 180. And when we solve this for y equals 180 minus 7x plus 30. But then if we go to the triangle is y plus 40 plus 3x plus 10 equals 180, because all the angles in the triangle add up to 180. And if you bring this in down here, in for y, you get 180 minus 7x plus 30 plus 40 plus 3x plus 10 equals 180. And when you subtract 180, you can see that cancels. When you add 7x, when you subtract 30, you end up getting 40 plus 3x plus 10 equals 7x minus 30. And you should say to yourself, oh, that means that the exterior angle equals these other two.
Right. Yeah.
And so you either use the exterior angle theorem because you remember it, or you're like, oh, you just prove it doing this. So however you want to do it, I want you to find the value of x though for us, please. And then we'll determine whether it's isosceles or not.
Yeah. X equals 20.
20, okay. So if we go back to our drawing here, I'm just going to grab it and move it down. So if x is 20, okay, that means that this up top here is 7 times 20, 140 minus 30, that's 110 degrees. And then this one down here, 3x plus 3 times 20 plus 10 is 70 degrees. So then this is also 70 degrees because the two angles have to add up to 180. So is this triangle isosceles? Yes, it is. Because the angles are the same. The base angles are the same.
Okay.
Okay, a couple of I don't know if you've covered this. You haven't done Pythagorean theorem yet in this class, have you? You're on chapter 7.
Yes, we haven't
Okay.
done it yet.
All right. I think you know enough though to do this next one. Okay, find the perimeter of a rhombus whose diagonals are 10 and 24. So I always think of a rhombus as a pushed over square. And the reason I think of it that way, because then I know that these are all the same, but it's just pushed over. So it looks like this, and I just don't really kind of get how they can do this, but they're saying like that one's 10 and this other one is 24. Now, what's really important about the diagonals in a rhombus is that they bisect each other. So it's not so much that you care about that it's 10, it's that it's 5 and 5. And then when you cut the other one in half, it's 12 and 12. And more importantly is they meet at right angles. Because now you can find the third side of the triangle. I know you haven't covered this. Feels like though it should have been covered. I don't know. But I'm just throwing it out there in case you do need that for this.
Okay, thank you.
Okay, so this question asks if the lines are parallel. This is the converse of, hey, they're parallel and do a bunch of stuff. So before you can answer whether they're parallel, you need to solve for x. And I want you to use this information right here to solve for x, please.
Okay. X equals 40.
X equals 40. So what that tells you is that this other angle is 80. And if we put X equals 40 down in the last one, it's 3 times 40, which is 120, minus 30, which is 90, which makes this other one, what does it make this other one? Also 90 degrees. So are these lines parallel, or what would be true if they were parallel? What would be equal, or what would add up to?
90 and 100 would have to be the same.
Yeah, they'd be corresponding, or maybe the 80 and the 90 would also be corresponding, or 80 and 90 would have to add up to 180, but they don't. So
Right.
the way this problem would be maybe be written differently is like, which of the following values of X makes the lines parallel? And maybe there's one where this X plus 40 equals the 3X minus 30, and you could solve that. Looks like it might be like 35 without the 100 there. Stuff like that. So I'll just throw a few other like formulas at you real quick here. We don't have a ton of time left. Midpoint formula, sometimes that gets on here. X1 plus X2 over 2. Y1 plus Y2 over 2. Distance formula is X2 minus X1 squared plus Y2 minus Y1 squared, square rooted. These are good to get down for this. Sometimes you get a question that simple, like what is the midpoint or what is the distance? And you don't want to miss those. Last thing I guess I'll throw at you is we've talked some about bisectors, but a trisector, and it could be an angle, cuts the angle into three equals. You can also trisect a line so that all parts are equal, like that.
Okay.
That is it for us for tonight. I will send you the notes here shortly. Thank you so much for letting me help you, and I hope your test goes well, and we'll definitely get going again next year. But that is it.
Okay, thank you.
You're welcome. Have a great rest of your night. Great holiday.
You too.
Bye now.
Bye.